Hi guys, this is Abdul Mohamed back again on Learners Connect. So last week, for those of us that were with us, so in aspect of the biostatistics that we're looking at, we've talked about the standard deviation, the importance of the standard deviation, and also the mean deviation. So we are going to be looking at why is it necessary this time around to study summarization of data and also the importance of frequency distribution in data. Now, let's say summarization, they say, is very necessary as the key root of organizing and making sure your data is very well in a stable position before you be able to make your analysis. So now, with the help of frequency distribution, we were able to organize and summarize our data. Now, what is frequency distribution? Frequency distribution shows us the number of occurrence of a particular set of data in a given sample. So when we are talking about our frequency distribution, it shows us the number of occurrence of data in a particular sample. It is very necessary for us to understand how a particular sample is being occurred in order for us not to make mistake of doing judgments that is wrong. Because for example, we might have samples that the number of occurrence might lead to an error. So if we really know how occurrences are being organized, then we will know how to deduce our values. So now we'll also be looking at different aspects of the frequency distribution and how we can also make use of frequency distribution. Now, let's see, we have relative frequency, which is frequency over number of total frequency multiplied by 100 all over 1. So the essence of this relative frequency in frequency distribution is for us to know how far is the margin of the particular occurrence of data from the normally organized rate that is expected to have. So it is used to check, hope there will be no errors or mistake when you are making your conclusion in the occurrence of your frequency. That is the essence of the relative frequency. So now, let us say we have an example of blood sample of 40 students in a biostatistics class. So 40 students blood sample of 40 students in a biostatistic class. So let's say we have a sample test. So we have our AB, we have our B, we have our O, we have our O, we have A, then we have B, we have AB, we have A, we have B, we have O for 3, we have our A, we have our AB, then we have our B, we have B, we have A, we have B, we have our A, we have O, we have A, we have AB, we have B, then we have B, A. So these are the number of blood groups that we have. And I think there are still more of them. We have B, we have A, B, we have our A, we have O, B, A, B, then we have O, A, B, and A, then we have B. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, these are the 40 samples of the blood groups that we are having. So we want to see now how we can actually deduce the frequency for this. So we are going to construct a frequency table for it. So the first one we'll be talking about is we talk about the class, which is we have our A, B, O, and AB. We'll talk about the tally. So you are going to draw a tally for it. Then we have our frequency. Then we have our what? Percentage of what? Frequency. Now this percentage of frequency is used to represent our relative frequency. So it's to tell you that when we are calculating the relative frequency, it has to be what? Percentage. So now let's draw our line for it. This class shows us the number that we are going to have. Now for A, we are going to count number of occurrence for A. That's our frequency. So what are the number of occurrence for the first one, which is our A? You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11. Okay, we have 11 for frequency. So when we are writing it in our tally, we are going to draw 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and 1. So this is how we represent it in our tally. So this is 11 for the first one. Then the second one, which is B, we have 1, 2, 3. We have 4, 5, 6, 7, 8, 9, 10, 11, 12. So we are going to have what? 12 for the second one. So you draw it. When it reaches the fifth one, you cross it. 1, 2, 3, 4, 5, 1, 2. So that's how we do our tally. So we check the next one, which is O. O is 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to have 9 for O. So you write your 9. 1, 2, 3, 4, 5, 1, 2, 3, 4. So we move to the next one, which is our what? A, B. So let's look at A, B. We have 1. We have 2, we have 3, we have 4, we have 5, we have 6, we have 6 for this, 1, 2, 3, 4, 5, 6. So move to, I think that's all. We have A, B, O, and AB as our class values. So now, since we've gotten our class values, we have to check the total number of frequency that we have. Now, what is the total number of frequency? The 6 plus 9, you have 15, 15 plus 12, you have 27, 27 plus 11, you have 38. That is the total number of frequency. So to check the total number of frequency is what? 38, right? 15, 27 plus 11, that's 38. That's our total number of what? Frequency. Now, what is the total number of what? Relative frequency, which is measured in percentage. Now, the total number of relative frequency. How do we get the relative frequency for this? I told you earlier that if we want to calculate our relative frequency, it's simply our F, which is each of the frequency divided by the what? The total frequency we have. The total frequency times what? 100 over 1. That would be our relative frequency. So for the first one is 11 over 38. So you have 11 divided by what? 38. We're going to have what? Times 100. You have 28.9. 28.9%. So the next one will be 12 divided by 38. We have 12 divided by 38 times 100. You have 31.6. Then you have 9 divided by 38 times 100. You have 23.6. Then you have 6 divided by 38 times what? Times 100. You have 15.78. So if you add everything together, 15.78, it should add up approximately 100 value. That's 1.6 plus what? 28.9. So you're going to have, due to decimal error, you're going to have approximately 100%. So you can see that adding the relative frequency, the properly organized frequency distribution, you are supposed to arrive at what? 100%. Okay? Or approximately value should be what? 100%. So having noticed this, this is how we get our frequency distribution. Now, if we are not asked now which one will have the highest number of occurrence, then it should be the plot sample with B that will have the highest number of occurrence. Why? Because it's the one that has the highest frequency. So that is how we calculate our frequency distribution. So possibly you can be giving group or ungroup data to calculate the frequency distribution. Now you make use of group data when your range is above what? 20. Remember in our last class, for those of you that been with us, when we have our last class on biostatistics, we actually talked about range. So we said range is the differences between the higher number and the lower number. So this simply tells us that what? That if the range, you are calculating your frequency distribution, if the range is greater than what? 20, then it is a group data. Then it is a what? Group data. So your frequency distribution should be worked on what? Group data. This simply means that your range, when we're talking about range, if you can remember, it simply means what? The highest value or highest data value minus what? Lowest data value. So your highest data value minus your lowest data value is your what? Range. So if your range is greater than 20, then it is a group data. And if the range is less than 20, then it is ungrouped data. Okay, that is it for the range. So now we are going to see what are the importance of frequency distribution. Now the importance of frequency distribution is to make sure that your data are organized in a meaningful way, and to also determine the nature and the stages of your data. So you'll be able to understand the values and the characteristics or the variables of your data in a very, very organized manner. So without understanding the frequency, then there will be a problem. So we have different types of graph in frequency distribution. So we'll be seeing different types of graph for frequency distribution. I'm going to talk about the measure one that we have. So we are going to look at the measure ones that we have. So what are the measure, this thing we have? We have the line diagram as the first one. We have our histogram. We have our frequency polygon. Then we have our cumulative frequency curve. So let's talk about these four measure types that we have. We have the line diagram, we have the histogram, we have the frequency polygon, I will also have the what? We have the cumulative frequency curve. So looking at the first one, which is the line diagram. A line diagram is a form of a graph used to represent frequency distribution of data that have actually changes over time. When you are relating a particular values of data over time, then we make use of line diagram. So let's say you are checking a particular species, their rate of consumption of a particular meal or anything at all you are working on, but you are relating it with time, then you make use of your what? Line diagram. Sometimes, mostly, your line diagram can be a straight line, can be linear in nature. Let's say your line diagram depends on what you are working on. It can be, let's say your values can be linear, organized in a linear manner like this. So we can make use of this to represent your what? Your line diagram. That is, whatever species, let's say we are working on a species, their rate of food consumption over time. So when you are comparing particular values of data with respect to time, then you can make use of your what? Line diagram. So we are going to, how do they occur? How do the consumption of their meal occur over time? So you want to check the frequency of a particular data characteristics with respect to time, then we make use of a what? Line diagram. So what we'll be looking at next is our frequency, our histogram. Now, how are histogram done and what is the function of it? Now, it is used for logical arrangement of what? Range, to show the ranges of data, the difference in the range of particular data. How are they organized? What is the difference in their range? Then we make use of what? Histogram to depict that value. So histogram is very simple. So can also be used to check the rate at which a particular abiotic factor, for example, the rainfall, happens with respect to time as well. You can make use of what? Histogram. So it shows the range at which something occurs. What is the level of heat in a particular time? What is the level of this? Let's say, what is the level of rainfall in so time, or which month do we have highest level of rainfall? So showing the range of this substance, we make use of our histogram to represent our values. And most times, the rectangular lines drawn in histogram are mostly packed together. They are not separated. So you are going to have something of this nature. So this side can represent the amount of rainfall, and this side can represent the what? The months at which we have the highest level, or the time at which it changes. So you can see this represents the ranges of which they occur over time. So we make use of what? Our histogram graph. So let's say this one occurs in the month of what? June, and we can see that it's in the month of July, August, and thereabout. So this is how we make or represent our histogram. So the next one we'll be looking at is our frequency polygon. Now, how is our frequency polygon? Frequency polygon, also known as frequency distribution polygon graph. We have, okay, let's create space for it. So the third one, talk about frequency polygon. Now, our frequency polygon is usually like the shape of histogram. So it does the same function too, but in this case, after you've done your histogram, just to check the values, it is being erased, and it is a line that will be shown or is going to appear. So showing the range of values of your data. So let's say we make use of histogram initially to depict our value. We are going to have something of this nature. So let's say our markings end here, something like this. Then we can now trace it. So when we trace our values like this, the essence of drawing your histogram initially is to mark out the actual point in order for you not to make mistakes. So you mark out the actual point it tallies with, following your dimensions. Then after that, you can use a light pencil for that. Then after that, you can simply erase the histogram line drawn. Then you leave the actual frequency polygon.